Today we will start the new topic, that is balancing chemical equation. Or first of all we have to know that what is balanced chemical equation. Balanced chemical equation, the equation in which the number of atoms of each element in the reactant and product sides are equal, is called a balanced chemical equation. I said number of atoms in each element in the reactant and product sides are equal. This is reactant side, this is product side. Number of each element. Here in this reaction, zinc, hydrogen, sulfur, oxygen, the elements. This side also same elements. Now what we have to do, we have to check the number of atoms on both these sides. See here, zinc 1, this side also 1, hydrogen 2, here 2, hydrogen 2, this side also, sulfur 1, this side also sulfur 1, oxygen 4, here oxygen 4. Means that both these sides the number of atoms are equal, hence it is a balanced chemical equation. Now when we are knowing the balanced chemical equation, what is unbalanced chemical equation? The equation in which the number of atoms of different elements on the reactant and product sides are not equal is called balanced chemical equations. Unbalanced, here it is unbalanced chemical equation. The unbalanced chemical equation is also known as skeletal equation or a skeleton equation, whatever you say, skeletal or skeleton. Here example, we have taken that aluminium reacts with oxygen to give aluminium oxide. Here in this one element I have written here number of atoms on reactant side and number of atoms on product side, as we have written here also. Aluminium 1, but here 2 atoms of aluminium. Here in this case oxygen 2 atoms, we have written here 2, here oxygen 3 atoms, we have written here 3 atoms. Getting? Hence it is an unbalanced chemical equation. Why? Because oxygen atoms are not balanced, aluminium is also not balanced. This is called unbalanced chemical equation, or simply we can say skeletal equation. Now we move on to the balancing of chemical equation. Balancing of chemical equation. See here, steps involved in the balancing of a chemical equation are as follows. There are 5 steps for balancing the chemical equation. First of all, we will go for the step 1. Write the equation in the word form. Word form. Here I have taken one example also. You can see hydrogen gas reacts with chlorine to give hydrogen chloride. So the step 1 is write the equation in the word form. Word form. Hydrogen reacts with chlorine to give hydrogen chloride. This is word equation. Now step 2. Write the skeletal chemical equation. Skeletal chemical equation. I have written skeletal chemical equation means unbalanced chemical equation. Hydrogen, we have written here the symbol of hydrogen and the formula of hydrogen, H2. Chlorine formula, hydrogen chloride formula. This is unbalanced. Why unbalanced? Because 2 atoms of hydrogen are here, but here only 1 atom. Here 2 atoms of chlorine, but here only 1 atom. Therefore this is a skeletal equation. Step 2. If in a question directly this equation is given, then we don't have to write this word equation. We don't have to write this word equation. This step 1 is word. Now step 3. List the number of atoms of different elements of the reactant and product. Different elements of reactant and product, I said. Step 3. First we have to make a table in which we will write element, number of atoms on left hand side, or we can also write reactant side. Number of atoms on right hand side, or we can write product side. Yeah, number of atoms on product side. Hydrogen and chlorine, 2 elements in this reaction. Now see 2 atoms of hydrogen. Here only 1 atom of hydrogen. 2 atoms of chlorine and only 1 atom of chlorine here. You can see. What you see that this is unbalanced equation. We have checked the step 3, list the number of atoms, the different reactants and product side. Now step 4, to balance the chemical equation, select the compound which has maximum number of atoms. Step 4, biggest formula, maximum number of atom. Here HCl only, here only hydrogen, this one is hydrogen, this one is chlorine, here hydrogen and chlorine both, therefore the biggest formula is HCl. Atom with highest number, in step 4 we have to choose that one. Highest number, you can again see in this one, in this case both are having same number, 1 atom of hydrogen and 1 atom of chlorine, so we can take either hydrogen or chlorine. Now we have to balance. How we balance it? We multiply. Here it is written that multiply the symbols and formula by the smallest possible number to balance the elements having maximum atoms. Here we have taken, suppose we have taken hydrogen, so to balance here it is 2 atoms, so we will have to multiply by 2 here. 2 atoms of by 2 we have multiplied here. Now after this multiplication, again we will make a table. We will check here element hydrogen chlorine, left side right hand side, number of atoms are equal on both the sides. Check here, 2 atoms of hydrogen, 2 atoms of hydrogen, 2 atoms of chlorine, 2 atoms of chlorine also. Means that as the number of atoms of each element are equal on both the sides, thus the above equation is required balanced equation. In this equation, the step 5 is not taken here because there is no element left to balance. One more example we are going to take here. Example is iron reacts with water to form iron 2,3 oxide. Iron reacts with water to form iron 2,3 oxide and hydrogen. Iron 2,3 oxide, the valency of iron. Variable valency, it shows variable valency, transition element, iron is transition element, it shows variable valency. Now here step 1, see, iron reacts with steam, that is water in the form of steam, gives iron 2,3 oxide plus hydrogen. Iron 2,3 oxide plus hydrogen. Now the step 2, we will write the skeletal equation, that is iron, the symbol of iron is Fe, steam, that is water in the gaseous state, that is H2O, iron 2,3 oxide Fe3O4. Here FeO and Fe2O3, FeO and Fe2O3, when they combine they form Fe3O4. This is called iron 2,3 oxide. This is called iron 2,3 oxide. Here the valency of iron is 2, here the valency of iron is 3 in this case. Therefore it is written iron 2,3 oxide, hydrogen H2. Now step 3, number of atoms on each side, that is LHS or RHS, or we can say reactant and product side. In this reaction, iron, hydrogen and oxygen, 3 elements are there. We have written in the table elements iron, hydrogen and oxygen. Now on the left hand side, that is the reactant side, see iron 1, here iron 3 on the product side. See hydrogen, 2 atoms of hydrogen, here in this case 2 atoms of hydrogen in the product side. Now the third one, oxygen, you see here 1, here 4 atoms of oxygen. Therefore this is unbalanced equation. Now the step 4, we will have to choose the biggest formula, that is Fe3O4, the biggest formula, and the number of atom with highest number, that is oxygen, which is with highest number, 4 atoms of oxygen. First we will have to balance this oxygen atom in this formula, biggest formula. Now Fe, what we have done to balance oxygen in this equation, here 4 atoms of oxygen, here 1, we will multiply here by 4. What we have done, we have multiplied here by 4, 4 H water H2O, gives Fe3O4 plus H2. Once again we will form the table. Element iron, hydrogen, oxygen, LHS, you see that is reactant side. Iron 1, again here 3, no change here. Hydrogen 4 into 2, that is 8 atoms of hydrogen present here. In this case only 2, the number of hydrogen here 2, but here 8. Why? Because we have multiplied this equation by 4. Now 8, hydrogen 2 here. Now see oxygen, 4 atoms of oxygen. You can see here also 4 atoms of oxygen. Therefore oxygen is now balanced, but oxygen is now balanced only. The step 5, what we have to do, we have to balance the rest atoms also. So see here, after balancing this, we are going to balance hydrogen atom, which is 8 here 2. For this, what we have done, we have multiplied hydrogen by 4 H2. 4 into 2, that is 8 hydrogen atoms. Again we will draw the table. Here reactant side, the product side. Iron, see here 1, here 3, no change in the case of iron. Hydrogen 4 into 2, 8 atoms. Here again 4 into 2, 8 atoms. Now hydrogen is being balanced. Now see oxygen, same thing, no change, 4 atoms of oxygen, and here also 4 atoms of oxygen, but still we are lacking in the balancing of iron. Next step, in this step we will balance iron. See here 3 atoms of iron. We will multiply this one by 3. See here, we have multiplied this iron by 3, and this iron, after multiplying, this reaction becomes 3Fe plus 4H2O gives Fe3O4 plus 4H2. See this one. Once again we have drawn the table. Iron, 3 atoms of iron. Here also 3 atoms of iron. 4 into 2, that is 8 atoms of hydrogen. Here 4 into 2, that is 8 atoms of hydrogen. Here 4 atoms of oxygen. Here 4 atoms of oxygen. Means each and every element is now equal on both the sides. As the number of atoms of each element are equal on both the sides, thus the above equation is the required balanced equation. Similarly, we can balance but more reactions for practice.